You're welcome to the last video clip on bearings. You're still on solving general triangles. This is Iniking video tutorial. In this video clip, we are going to look at two questions. On the screen here, we have the first one. I told you that Ayo travels a distance of 24 kilometers from X on a bearing of 060 degrees to Y. He then travels a distance of 18 kilometers to a point Z, and Z is 30 kilometers from X. 1. We are required to draw the diagram to show the positions of X, Y, and Z. 2. We should find the bearing of Z from Y. And 3. We should calculate also the bearing of X from Z. Let's set out and see how to do this. The first statement states that what? That the bearing of Y from X, we are told that from X, the bearing is 060 to Y. So we are taking our bearing from X, as you can see. That's our X. So the bearing is this angle. That way, from the north direction of X, we take 60 degrees, and that runs us up to Y. We are told the distance there is 24 kilometers. We are then told that after getting to Y, it then travels a distance of 18 kilometers to point Z. Now we don't know where Z is. Z can be anywhere around Y. But we are also told that Z is 30 kilometers from X. So I can go up there and locate my Z, which is 30 kilometers from X. Or I can decide to take something more convenient. I come in this direction, there, and then I look at 30 kilometers, obviously longer than XY. Something like that. That pays me. So that's it. So that's the position for what? Of X, Y, and Z. Y is what? 24 kilometers from X on a bearing of 60 degrees. We have not given any other bearing. But we are told that Z is 18 kilometers from Y, and Z is also 30 kilometers from X. That gives us the diagram. So we have taken care of question 1, or the first part of the question. The next is that we have to find the bearing of Z from Y. How do I find the bearing of Z, this location, from Y? What does that mean? It means that if I want to go to Z and I am at Y, how do I go? What direction will I take? I say, okay, I'll simply take this bearing, coming from the north direction there, up to the line linking Y to Z. And how do I get this angle? I say, oh, I know from here to this place is 180. If only I can find this angle, then I'll subtract it from 180. I said, okay, fine, there's no problem then. Do I know the whole of this? If I can get my Y, this is angle Y. I know this is 60. How? Because this is alternate to the 60 degrees that was given to me there. Yes. The two blue straight lines are what? Are parallel. So this is 60 and this is also 60. And so in that case, I need this. Let me call this place alpha. My bearing will be 180 minus that alpha. That is, this is my 180, and then I subtract alpha from it, and that will give me the remaining part. So what is alpha? Oh, alpha is in the angle Y. Alpha will therefore be angle Y minus 60. Yes, because I've just said this is 60, alternate, and then this is alpha. The two of them add up to give us angle Y. So my objective now first is to go and find the angle Y. Getting the angle Y will give me alpha, and I come back here, substitute here to give me 180 minus alpha, which is the bearing of Z from Y. But how do I get the angle Y? I look at the triangle carefully. I can see that all three sides are given. And I remember cosine rule. That's the master. Once all three sides are given, we can find any angle. This is side Y, facing angle Y. This is side X, facing angle X. And this side Z, facing angle Z. I develop Since I'm looking for angle y, I develop an equation that has to do with y. I say, okay, y square, my cosine rule, will be x square plus z square minus 2xz, and then the cos of the angle facing that y, which is that. And mind you, this is what I'm looking for. So what do we do? Let's make this the subject of the formula. I transfer the whole of this onto the right hand side. We have 2xz cos of what? Y equal to x square plus z square. I transfer y square to the right hand side. It gives me y square. Sorry, I've transferred this one to the left hand side. And since I'm looking for y, I just say, oh, my cos y will therefore be what? X square plus z square minus y square divided by 2xz. If you are frowning or you are angry that you don't know where I got this from, please go and look at solving general triangles cosine rule. We have explained cosine rule there. Check for what? Solving general triangles cosine rule. You can also see sine rule there too. From this, we can now substitute the value of x, which is 18, the value of z, which is 12, and the value of y, which is 30, into this expression. I'll be able to get cos y, and from there we can find the value of y. Now let's do that. So that's it there. We've said that we've agreed that the bearing of z from y is going to be 180 minus alpha. That's our alpha indicated in our diagram. That's the small angle there. And 60 has been clearly stated there that 60 is alternate to the 60 this way. So we are in line. So that's it. Cos y, as we have just derived, is equal to that expression. Substituting the values, we have this. Manipulating the numerator, that gives us 0 over 864. And that's 0. Oh, wonderful. So cos y is 0. In that case, that means y must be 90 degrees. Oh, this is 90 degrees. That means alpha will be 30. If this is 90, that means this must be what? A right angle triangle. Why don't you go and try it and find if 30 square will give you 24 square plus 18 square. I'm sure you will get that. This is 576, if I'm not mistaken. This should be something like 324. Yes. Okay. So we call 30, 24, 18 a Pythagorean triple. You can see. So that was even a right angle triangle right from the beginning. So now we know that angle y is 90 degrees. We can now find our bearing. Let's get first alpha. Alpha is y minus 60, as we have said earlier on. So our alpha is what? Y minus 60, which is 30 degrees there. So the bearing is 180 minus alpha. This angle from here up to that point will be 180, the whole of this, subtract alpha from it. So that gives us the bearing of z from y. Next, we look at calculating the bearing of x from z. Our screen is fully used. So let's delete some of this calculation platform and create some space. How do I get the bearing of x from z? That should be the question on your mind now. X from, take note, from z. I want to go to x from z. That's the line taking me. Okay, what angle would that be? Okay, I'll be coming from here. I'll go, that's 180 plus this angle. Okay, 180 plus that angle. And that solves the problem. That should solve the problem. But if I can also find this angle here, I can subtract that from 360. Yes. I think that helps me. Because the bearing is all the way from here that way. And we have just this left to make 360. The small angle here is same thing as alpha. Yes, you will agree with me. So this is 30 degrees. What about this other angle? That's my angle Z. Oh, so the bearing is going to be 360 minus angle Z and also that angle 30 degrees. So the problem now is, what is angle Z? Well, since I know this is a right angle triangle, I can just jump and use my sine rule and obtain that. I don't need to kill myself anymore. It's okay. Let's go ahead and do that. That's the bearing. 360 subtract z plus 30 from it. And there we are using the sine rule. We say sine z, that's z, that angle, is going to be opposite 24 all over hypotenuse 30. Why is it the hypotenuse? Because this is the 90 degrees and this is opposite because it's facing our angle z. So that's 24 over 30, which gives us 0.8. Computing that, z will therefore be the sine inverse of 0.8 and z is equal to 53.13. Now we fall back again to find what we are looking for. 360 minus that, and that gives us 276.9 degrees. I'm sure we're all happy with that. So we are done with the first example. Let's quickly move on to the second. The second question states that three towns, P, Q, and R, are such that the distance between P and R is 90 kilometers. If the bearing between, Sorry, I had to make some corrections there. Let's take that again. Three towns, P, Q, and R, are such that the distance between P and R is 90 kilometers, and the distance between P and Q is 50 kilometers. That information does not give us any direction, so we'll continue. If the bearing of, please let's take this off, of Q from P, if the bearing of Q from P is 75 degrees, the bearing of Q from P, please take off this between, that's wrong. The bearing of Q from P is 75 degrees. Now with that information, I think we can locate Q and P first. That's it. From Q, from P, we are told that the bearing is 75 degrees. The bearing there is 75 degrees, and that P and Q, the distance between the two of them is 50 kilometers. So that's it there. And then the next one says that, and the bearing of R from P is 310. 310, that's just 50 degrees short of 360. 310 means from P, take note, we are taking it again from P, looking for R, that's 180, 270, 40 degrees more to give us 310. So our R should be somewhere along that line. And why did I say 50 degrees short? Yes, if that's where my R will be, and the angle from here down there is 310, then that means we have just 50 degrees left. So let's put that neatly. That's it there. So the 310 has been located from here that way, and then we have 50 degrees left because 360 minus 310 will give us 50 degrees. The question now demands that we should find the distance between Q and R, that is the line joining R to Q. So if I take R to Q there, that's what we are looking for. That's it. Now we can see we have a triangle, of course not a right angle triangle as you can see. So Pythagoras theorem will not come in here. Having a right angle triangle, we have two of the sides given to us, and we are required to find the third side. That side is facing this angle P, so I can label this as small p, I can label this as lowercase r and lowercase q. Of course, you will agree with me that cosine rule will go straight since we have two sides and the included angle. 50, 75 gives us 125 for that angle. So I simply say, okay, using cosine rule, p square will be equal to q square plus r square minus 2qr, the cos of angle P. Take note, my angle P is 125. If I substitute, Q is 90, so that will be 90 square plus 50 square, 50 square, minus 2 times 90 times 50, and the cos of 125. Now, cos 125. 125 is in the second quadrant, and cos is negative in that quadrant. So the equivalent will be cos of 180 minus 125. That should give me minus cos of 55. Let's substitute this in a neater form. That's it there. Angle P is 125. We're using cosine rule, as we've just agreed. And that's the substitution done neatly. And there, cos 125 is going to be replaced with minus cos 55, which is done there. 90 square is 8100. 50 square is 2500. That's 22,500. You add that up, we have 10,600. 2 times 50 is 100 times 90. That gives us 9,000. So that gives us this here. Now opening this bracket, the minus and this other minus will become plus. So we have P square equals to 10,600 plus this. Adding that 2 up, we have our P equals to the root of 15,762.2, which gives us 125.5. So that's the distance between Q and R. The next is, what is the bearing of R from Q? The bearing of R from Q. The bearing of R from Q. Again, we are looking at the line RQ. How do I go to R coming from Q? That's what the question is simply saying. The bearing of R from Q. It's okay if I take the angle from the north direction there. I'm going to roll all the way to this point. It's okay. From here down there. How do I get that? This is 180 or at this point. What about this angle? Okay, I can see this is alternate to 75. So this will be 75. Oh, all I need is to find this other angle here, Q. That will give me what I'm looking for. Let's do that neatly. Yes, I've just said this is 180 plus 75 plus Q to give us the bearing running from Q to R. So that will be 180 plus 75 plus the angle Q. Therefore, our objective is to go and find angle Q. Now, already we know RQ, so which means all three sides are known. We can use sine rule. If you like, we can still use cosine rule, but I think sine rule is sweeter. So let's go ahead and use the sine rule to find angle Q. That's it there. So using sine rule, we take the ratio of the side P, which is this, against the sine of the opposite angle, that's sine P. And since we are looking for Q, we use Q all over the sine of Q. So now angle Q is the only unknown there, so we can find our Q. Substituting values of P and sine P, we have this. Side Q is 90. Manipulating that. If we rearrange, we have cross multiplying. Remember 125 can be replaced with 55. And sine is positive in the second quadrant. So we have it as sine 55. So we throw away sine 125 there and replace it with sine 55. Mind you, this is not compulsory. If you are using a calculator, you can just go ahead and key in your sine 125. You'll get your exact value. But if you're using a 4-figure table, you have to do this computation. Cross multiplying here, we have 90 times sine 55, giving us this. And then we have 125.5 times sine Q, giving us this other side. And then, since we are looking for sine Q, we divide both sides by 125.5. And that gives us this expression, which is reduced to 0.5874. Angle Q, therefore, will be sine inverse of that. That gives us 36 degrees. Remember we said our bearing is what? The bearing is 180 degrees plus 75 plus Q. How? Remember we came here, we said this is 180 plus 75 plus Q. And that's it there. So the bearing is 291. With that, we have come to the end of bearings and also the end of solving general triangles. It's been Iniking video tutorial. Thank you.